let me welcome you to the next edition of Mython AI Times. Thank you all for coming and joining online. I'm really happy to see you again. And in case you're here for the first time, welcome and thank you for joining. My name is Tonda Hoskovec. I recently joined Mython. I'm the organizer of Mython AI Times. And today's speaker is Petr Červa. He works at Nanotrix, and I believe both at Nanotrix and Technical University in Liberec. He is an assistant professor there. He teaches machine learning, so he has a lot of academic background as well. And today he will be talking about creating chatbots for courts, and well, in the end for the state as well. And I think that's really interesting to hear how they got everything through, all the checks and how they brought trust into the system. I wanted to ask everyone to remember questions and keep them for the end. I will then hand you a microphone if you're here. And if you're online, please just type into chat and I will ask the question for you. Yeah, today we are recording, and so expect the recording to appear on our YouTube channel. And I believe that's everything that I wanted to say right now. So I'm just gonna start being quiet and hand over to Petr. So please welcome Petr. Nice. So the floor is yours.
Thank you. Hello, everybody. At the beginning, I would like to thank Mr. Hoskovec for inviting me here. My name is Petr Červa, and I am head of AI lab at the Technical University of Liberec, and I am also founder of nanotrix.ai, which is our spin-off company. Today's topic is under the hood of a chatbot for the Constitutional Court. So at first, I have to introduce our lab. Our lab was founded 25 years ago. Originally, we focused solely on speech processing. We created Newton Dictate engine, which is used in Newton Dictate software. This software is deployed in many Czech hospitals as well as courts. We also created a platform for 24/7 transcription of various TVR programs for Newton Media Company. Recently, we have shifted our research to applications of language models. At the moment, we have a research project to develop recommendation systems and chatbots for libraries in the Czech and Slovak Republic. We solve this project in collaboration with Retrieval company from Brno. Now some basic info about our spin-off. Nanotrix was founded in 2025. We have been offering products on the market for 9 months. We offer chatbots, voice bots, and on-premise RAG system for companies. So what actually is a chatbot? AI chatbot in general is a program that communicates with users in natural language. It understands questions and responds in full sentences. However, chatbot in the context of city and institutional websites, it's enhanced search engine with natural language answers. It provides the users direct answers instead of links, and it also provides sources for verifying information. It's very important because the users need to have the possibility to verify the information which is found by the chatbot. Our chatbot minimizes hallucinations by using information only from the target website. This is really very important for our customers because we have provide only information that are available on the target website. Where can you encounter our chatbot? So at the moment, our chatbot is deployed on more than 50 websites. These include 35 cities and as well 6 city districts in Prague. In the Czech Republic, we have also chatbot on the website of city Trnava in Slovak. We also cooperate with several big hospitals, including hospital in Liberec, Olomouc, České Budějovice, Karlovy Vary, and so on. I think that our most important customer is the Constitutional Court of the Czech Republic. We cooperate with the Constitutional Court since the previous year, and we will have a chatbot on the website of the Slovak Constitutional Court starting from the 1st June. In these installations, we do not index only websites, but we also index documents of the courts. So in the case of the Czech court, our index contains more than 100,000 of court decisions. And in the case of the Slovak court, the number of documents in the index of our chatbot is lower. It's just 50,000 of documents. I think now we can try our chatbot. I can show you how it works. So I will try it. I will switch here. So here you can see our chatbot is a widget on the right down bottom of a web page. Now the widget is open, and I will paste here a question. The question is related to Mr. Turek, and it's the most important question. I will try to find the cursor. So I can click here, and I will be able to send the question. So does the president have to appoint Mr. Turek as a minister? It's a really important question. And you can see that the chatbot was able to find the answer in a few seconds. You can also see that you can vote. You can use thumbs to vote up or down. So you can if you like the answer, you can vote up. If you don't like the answer, you can vote down. You can also use voice input, and you can switch language here. Here you can switch language, and there is also info button. If you click this button, then you can read through terms of use of the chatbot. These terms of use were prepared by Constitutional Court. So this was our chatbot, and now I think I can continue my presentation. So now I will look under the hood of our chatbot, because our chatbot is a RAG chatbot. So what RAG means? Retrieval-Augmented Generation, or RAG. It's a technique. It adds a knowledge based on the target website to the large language model. The large language model has access to the complete website content, and it searches for answers in a local index. Then it responds based on verified sources, and it responds very quickly. This approach, RAG, solves two major LLM problems. The first is outdated data, and the second is unsupported answers. So this RAG chatbot answers only the questions which are related to the index of the chatbot, which is very good, especially for the Constitutional Court, because we cannot answer questions which are not related to the content of the documents. So the letter R stands for retrieval, That means that the most relevant text pieces for the query are found in the prepared knowledge base. The letter A stands for augmentation. That means that the found pieces are added to the query as context, and the AI model at the end receives not just the question, but also background material. And the last letter, G, stands for generation. The AI model assembles a natural response with source citations based solely on the provided material. How does RAG work? So we have two phases. The offline phase contains several processing steps. At first, we need to crawl the target website or the target content. We need to process all texts and pages. We need we need to split these texts into chunks. We need to calculate embedding vectors for these chunks, and we need to store all this information to a vector database. It's so-called data preparation phase. Then, on every query, we need to compute a query vector. We need to compute embedding vector for the query, and then we need to find similar vectors from our index to the query. We select closest chunks given this similarity, and then we call LLM model to answer the given question using query, found pieces, prompts, and so on. And then we can show the answer to the user. I will go now through these steps in more detail, of course. So the first phase, crawling, is really very important and hard part of our system. It's one of the key components of the entire system. The reason is that websites of institutions and cities are often unpredictable. There is a lot of endless calendars, cyclic links, invalid pages. We need to filter out all these and process all these things. These pages are no longer just simple static pages. There is a lot of JavaScript applications, server-side rendering. So usually we need to create a special profile for every target website. Moreover, important information is also hidden in documents. That means that we need to process PDF, DOS documents, and some other kinds of documents. And each web page goes through several steps, including page downloading, content filtering, and text cleaning. During page downloading, we need to automatically discover new pages within the given website. We need to support checkpoint recovery. We also need to rate our crawler because we cannot take down the given server. We use Playwright, full browser, which supports various formats. And of course, very important thing is that we have the ability to block specific pages or entire sections. We can block entire photo galleries and so on. We can also block all documents based on the date of their creation and so on. After that, we need to filter the content. So we need to define suppressed HTML text, headers, navigation. We need to suppress cookies, and we need. So that's the reason that why we have support for special profiles for unique websites. We need to deduplicate the pages. So we use hashing for deduplication, and so on. So this part of our system is really huge. The final step is text cleaning. We need to prepare text data for chunking. So we need to split the text into small parts. So we need to perform normalization of spaces and control characters, conversion. We convert everything to Markdown format. And there is also option for expansion of abbreviations and supplementing information. And finally, we perform text splitting and chunking, and we store these chunks in the database. The size of our chunk is 2,000 characters approximately, with a small overlap. Also, a very important question is how often we need to download the given website. So we usually download each website at night, every night, and we download selected pages containing news one times each hour. So the index of our chatbot is not old. Now about chunking. Chunking means, as I told, chunking means splitting text into smaller pieces. The reason is that LLM has only a limited context window, so it's not capable of processing unlimited context. So it's not possible to pass all our documents into LLM. We need to pass only the best pieces from all documents, only the pieces that are related to the given question. If we use smaller pieces, then we can expect more precise retrieval. There exist various splitting strategies. As I told you, typical size is around 2,000 characters. And we also need to have overlap. So chunks have overlap. This prevents information loss at the cut points. After that, we have to extract embeddings. That means that we need to convert chunks into numerical form and store it in a database. For this purpose, we use our own local models. These models are in our cloud. These models are under our control, and at Technical University, we are able to train this model. We are able to fine-tune various open source models for this purpose, and we are able to perform model adaptation for various domains. We also support for multiple embedding models. This is very important for the precision point of view. In practice, we use a combination of two complementary models with dimensions 768. The use of multiple complementary embedding models really improves the quality of retrieved chunks and the quality of answers. These embedding models capture meaning of the input text. They do not capture the used keywords. The most important thing is that chunks with similar meaning or similar content must have very close vector representation. So we select the models according to this criteria. In practice, we use PostgreSQL database with PG vector extension. And the process of embedded computation is fully separated from web scraping or crawling. So this was the first offline phase. Now I will talk how we process each query of the given user. First, we need to vectorize or convert the input query into the embedding by the embedding model. So we vectorize the input query, and we need to find the closest chunks for each input query. So here you can see the process here on the slide. So we have the input query. We use both our models. We perform vectorization, and then we use both these models to find the most similar chunks. Usually we select like 30 chunks for each, 30 closest chunks for each model. Then these results are interleaved by position. And of course, we filter out duplicates. So we need to deduplicate these closest chunks. Also, we have an option to add a few full documents for the closest chunks. So for the closest chunks, we add the full corresponding document. There is also a problem that vector search has some limitations. Let's imagine this signature of the Constitutional Court. In this case, vector search tries to look for meaning, and it generally struggles with numbers. So vector search is not good for searching by signatures. Therefore, we need to use a hybrid search approach. That means that first we use LLM model or regex expressions to try to extract a signature from the input query. And if we are successful, if we extract extract a signature, then we can perform direct matching, and we can search in document metadata index. And the found results by this approach are added with the highest priority to the retrieved content. So vector search runs in parallel as a complement to this classic retrieval. When we have the content, we can start to generate the answer. For this purpose, of course, we use LLM model, which handles formulating the answer. And the generation of the answer is based on chunks, which are closest to the answers, prompts, query, and the found context. We stream the answer in real time, including source citations. We put the citations into square brackets immediately to the generated text, as you could see during my short demo. Formatting is handled by the widget UI, and we can easily swap LLM. Currently, we use Gemini models. But of course, the situation of the market is changing dynamically, so we are able to switch the model. We try to optimize the model according to the price or performance ratio. In the future, of course, we would like to use a local model, but at the moment, the open source or smaller models are not so clever or are not so good in generating the response. So at the moment, we use a Google Gemini model in the cloud. The chatbot's behavior and responses are significantly influenced by prompts. We have various types of prompts. The first type is so-called global prompt, which applies to all projects. This global prompt contains basic instructions, some protection against prompt extraction. We add date and time and holiday information to this prompt programmatically. So our chatbot knows in each time what date is, what time is, and so on. We also use this global prompt to handle language information, to handle translations, and this global prompt is also used for response formatting, contact placement, bold text, citations, greetings, and so on. But this is not enough. We also need to have a local or project prompt, which is also very important and which defines rules for a specific project or for a specific customer. So, for example, we use this type of prompt to determine identity of the chatbot. For example, you are a chatbot of the city of Liberec. Your name is Liberec, and so on. If you don't know the answer, recommend and email. There are also some other instructions, project-specific instructions. For example, we use this project-specific instruction if there are some missing information on the website. We also use this prompt to correct facts or common errors. It's also very important, and for formatting rules. And both these prompts are used for generating answers, and can be, of course, easily changed by in admin panel of our platform. Here you can see the architecture of our system. You can see that we have core API, which is written in Python. It contains a job queue. You can see that we use Postgres SQL, as I told you, with PG vector extension, and this core API is connected to some other components, including widget UI, voice assistant, API. So if you don't like the appearance of our widget, you can create or integrate our chatbot into your website how you want, because we have API interface, so you can create our own implementation or user interface. And I think that what is a good sell point is that chatbot integration on the website is really very, very simple. We have a ready-made widget, and this ready-made widget can be integrated into a website just using a single line of JavaScript code, which is very good if you communicate with cities or hospitals. We have here a lot of options for additional functionality. I will show you something later, and our customers are connected to our platform, which is operated in our cloud, and we provide automatic updates to the latest version. So or our customers has the same version of our platform. As I told you, we have API, so you can create your custom UI implementation, and you can integrate our chatbot into the search bar if you want of your website. Now I have some details that make the chatbot. It's not correct answers alone are not enough at the moment. We need to have a range of other features which makes working with the chatbot easier. So one of the important thing is, of course, widget appearance. This is here we provide a rich customization options. You can change the name, colors, logos, welcome messages, info messages, languages. So everything is customizable, and we can customize it for our customers. Also, the good thing is the multilingual support. We have full support for selected languages. Usually, eight is enough, and it gives the users the option to search the given website content in their foreign language. It's a really valuable thing, because then you don't need to translate the whole web page. Our chatbot can replace the translation of the whole website. As I told you, there is a possibility for voice input, so you can ask questions by voice. If you click the button, the small button here down, transcription is performed in real time. Of course, we support for various languages, and this option is widely used on mobile phones. As I told you, the users can rate, can use thumbs to up thumbs or down thumbs if they like or dislike the answer. So it's user feedback. This user feedback allows us to identify or some problematic questions, and it's basis for iterative improvements, because we can see these thumbs in the dashboard panel of our solution. So our chatbot has a dashboard. This dashboard is available for administrators, for us, but is also available for our customers. It contains overview of questions and answers and some statistics for a selected period. I think that now is a good time to show you the dashboard. So I will try to switch to the dashboard. So at this moment, I'm logged in to the dashboard of the Czech Constitutional Court. I will show you some statistics. I have to click here at first. So now we are in the dashboard part, and here are some statistics. So, for example, I can switch here. I can switch here. So you can see that this year, starting from the February of this year, we have more than 30,000 of questions, and you can also see that the average time to the first token is below 4 seconds. That means that in average, our chatbot is able to generate the first token of the response below 4 seconds, which I think is quite good. And then we need, let's say, 3 more seconds to generate the whole output. But it depends, of course, on the LLM model used. You can see that majority camps uses desktop. There are some, of course, there are some people using mobile phones. Here is the distribution over various languages. Of course, more than 97% of questions is in the Czech language. There are some categories, query categories, and there are some statistics, some peak hours. So you can see that our chatbot is used mainly during working hours, of course. So this was the overview of the usage. For example, you can see a peak here. Do you know why? Do you have any idea? This is the first day where our chatbot was introduced or launched, and there was an article on the Novinky website, and this article was about President Petr Pavel, and that the authors of the article tried to use our chatbot, and they give our chatbot the question if the President of the Republic has to appoint Mr. Turek as a minister or not. So the people on the website of Novinky read the newspaper article and then went to the website of the Czech Constitutional Court, and they tried to answer our chatbot with the same question. And there was really a lot of people who were very angry that day. So there was a lot of negative comments. I think that these comments were not about our chatbot. These comments were about President Petr Pavel. So, but Constitutional Court told us that the response was good. There were no problems. It was all the answers were correct. So it was a test of the stability of our platform and of our chatbot. Now here is also, you can also, of course, you can also go through individual logs. So here you can see logs of the communication. So there are some tags. Like language, mobile phone, computer. You can see the time of the question. You can see pseudo identificator of the user. You can see the origin of the question, and of course you can click and you can see the detail. So you can see user question, you can see the response of the assistant, and so on. So this dashboard helps to webmasters because there are also some analytic functions. You can, of course, export these logs, and you can use these logs in some chatbot, and you can try to analyze them, because sometimes there are some missing informations on the website. So you can use these logs to identify missing information on your website, because you will see that in some cases the chatbot is not able to provide response because the information is missing on the given website. So it was the dashboard. Now I will try to go back to my presentation. I have just a few slides left. Now, what about internal data? Because we see the future of our company in on-premise deployments. We can run our rack system on the Kubernetes platform, and we are able to deploy this platform on-premise. This rack system has low computation demands. We need CPUs only. However, of course, there is still problem with answer generation. On premise, we can use some smaller language model, which is of course not so good as Google Gemini, or we can use hybrid mode or hybrid approach via a dedicated large language model hosted somewhere in the Azure or in some other cloud. At the moment, we have two companies. We started cooperation with Valbec company and with their touristic company, and both these companies are testing our rack system on premise. So it was my last slide. Thank you very much for your attention.
All right. Thank you very much for the great talk. Are there any questions? So if you're here in the room, I will hand over the microphone. Yep.
Hello, can you hear me? Okay, thank you for presentation. I have two questions. So first is, I'm curious, what do you do with the feedback, if it's positive or negative, the thumb? So I know what you can do, but do you do actually something with the feedback?
Yes, we can filter these thumbs up or down in the dashboard. We can export the corresponding question and answers, and we can of course modify our prompts, or we can modify the content. We can modify the content of the index. We can add some documents to the index of the chatbot. If the mistake is, for example, due to the fact that some document is missing in the index, we can also remove some document from the index. If the bad answer is given by the fact that we indexed some very old document, and so on.
And have you done anything that?
Yes.
Okay,
we provide support, especially in the first week, because in the first week there can be some mistakes related to the fact that some documents are missing in the index, that there can be some old documents. So it takes a few days to repair some questions.
Okay, thank you. And one more question. Who pay, like in your business plan or case, who pays for Gemini tokens? Is it you, or you somehow transfer all the costs to your customer? Is that, if it's not secret?
It's not secret. We sell it as a service, and so usually the city pays some amount and for each month for the service, and in this price the amount of conversation is unlimited.
So if some other chatbot comes to your website and starts like trolling you by pasting a lot of...
If it's a human, it usually throws off. It usually sends something like 10 questions, and because and I think that then everybody stops because it's very hard to get the prompt from our system, because we use techniques to block these activities. But and for some automatic systems, we have some rate limitation and something like that. But the risk is on our side, not on the side of our customer.
Okay, thank you very much.
Great, thank you. Right.
Hi, thank you very much for a nice talk and great product. I'd like to ask, I haven't caught what is the actually voice engine or ASR engine that you are using for the voice input, if it is possible to know.
Yes, we tried various ASR inputs, including our own, because we are the lab of computer speech processing. But at the moment, we use Soneox.
Soneox. Okay, thank you. And if I may, one more. In the example chart that you have shown us in the beginning, there the chatbot was actually confused because you used the name Turek, and it confused it with country Turkey and even Turkmenistan. How do you deal with errors like this? Because you don't like to see this in the output, do you?
Yes, of course, we don't like to see any errors in the output, but it's really difficult. This type of error was related to the English language, and in the Czech, it can also happen in the Czech language, of course. But if there is a mistake, like it's the same if there is a mistake in ChatGPT, but we can of course improve the prompt. We can modify the prompt. So in the project prompt, we can write that, for example, Turek is the name, is not the nationality. So we have a lot of options to correct particular answers, particular questions. But of course, we not correct everything, because the problem was given by the Gemini model, which was not able to determine if it's a nationality or name.
Yeah, thank you. Actually, no, there are many ways to correct that. The question was like, if you are considering some, specific one, if you have in mind.
Yeah, but there can be some ways to correct some specific type of errors. Of course, if we have application when there is a lot of types of errors of a certain type, we of course can try to use some technique to filter out these mistakes.
All right, thank you.
There was one question online as well. If you're willing to share which Gemini model you're using.
Yes, Gemini Pro is very expensive and is also slow. So at the moment we use Gemini Flash model.
Thank you. There was one question here.
Hi, thanks for the presentation. I just wanted to ask about languages. So your documents are in Czech, but somebody asked a question in Spanish. So you translate the question, or
we use global prompt, and at first we translate the input question into Czech language. Then we find the related content. We generate the answer in Czech, and then we translate the answer into English.
Okay.
Into Spanish, sorry.
Okay, yeah, thank you.
Yeah, sorry, I'm not sure who. Yeah, thanks.
Hey, I'm just about the embedding part, because to me that was the most interesting one, because that's something you do in-house, whereas the rest is basically whatever I can build as well on my own. So I'm super curious, if you don't mind sharing. You use any kind of evals? Why would it make sense to train your own embedding models rather than using off-the-shelf models from OpenAI or whatever, right? And also, what was the process in general? Because you also mentioned you use two different embedding models. I'm not really a professional, so I'd be curious why this is helpful, what kind of mistakes it prevents, or in general, how was the process? Because I think this is super interesting.
Yes, so if you use just one model, you are able to find, let's say, 80% of relevant chunks that are related to the input question. If you use 2 models, you are able to detect, let's say, 85 or 90% of chunks which are related to the given question, because each model is different. They are somehow complementary. So if you use more models, then you can find more relevant chunks. And there exist some data sets and metrics and papers for this. Yes, these papers show how beneficial is the usage of more than one models. There is a lot of papers around it. And of course, these models are small. So we are at the technical university, we are still able to train or fine tune these models. So we can use some open source model, and then we can use, for example, a data set with Czech language question from the dashboard. Yes, real questions and real answers. And we can use the input documents, we can create our data set, and we can optimize these models to find the best chunks which are really from the target application. So it's the reason why it gives sense to adapt or fine-tune a model for a given domain, because we can improve the accuracy of the query detection, of the content detection.
And so do you have evals so that, let's say, every so often you compare your results of your own embedding models to, let's say, using OpenAI embeddings?
Yes, of course, because the AI model is good, but he is good, but there are some open source models that are better. And if you combine the 2 best open source models, you can have better accuracy. And if you adapt or fine tune this model, this open source model, or if you adapt it using LoRa adapter, you can have also very good model. Then you can combine these 3 models, and then you have really much better results than OpenAI API model.
Cool.
And of course, you are not dependent on OpenAI, and you don't need to pay for vectorization.
Got it. So you do have to run your own infra as well.
Yeah, but it's pretty fast process.
And would you mind sharing the training process? How does that work? Because you've mentioned that you could take the queries or some documents and train it based on that. I honestly have no idea how this works. So if you wouldn't mind sharing a little bit, is it like manual process? Is it people? Are there people involved rating or?
You have question and you have a set of documents, and you need to find chunks from the input set of documents which are related to the input question. So you need manual annotation. You need to go through the documents, and you need to mark that this chunk is related to this question. This chunk is related, this is not. And then you simply measure if you were able to find these related chunks automatically given the input model. Yeah, of course, it's supervised learning.
Right. Any other questions? I'm gonna quickly check online, but we're slowly also running out of time. Yes, there's there's a question about the I believe the documents that you then embed. Sorry, do you only use the documents that you scrape yourself from the web pages, or can your customer also provide like a bunch of internal documents?
Yeah, he can provide a bunch of internal documents. Of course, if we are on premise, we operate just over internal documents.
Nice.
We can connect to SharePoint or.
Yep. So one final question there.
Just small question about fine-tuning of embedded models. Are you using like synthetic data sets for supervised learning, or you prefer to actually have like a human do it?
Yes, if we perform fine-tuning, then we of course prefer to use domain-specific data sets which are really related to our customer. So in this case, we have to manually annotate this data, or we can try to use AI for helping us with this process. So it's a combination of automatic annotation with some manual corrections and so on.
Okay, thank you.
Right. Maybe one question if it's yep.
Thank you. Sorry, one business question. So you have many customers from the public sector and some customers from the private sector. How would you compare them? Like, are there different demands? Are there some tricks you can share about dealing with the public sector customers?
It's so different. It depends on the people. There are some cities which are very fast. You can make the deal with them in 1 week. There are some cities, and you can spend 3 months here. They want your solution, but it takes 3 months before everything is accepted in the management of the city. And in company, it's maybe sometimes it's faster, but there are some other problems. So if you deal with a big company, it's like dealing with a city, I would say. So
Nice. So let's thank Petr again, please. All right, and I have a little bit more info, so I'm gonna switch the slides back just for a few moments. Yeah, hopefully if I can find my mouse. There it is. So I wanted to show once more the ad for a web page where you can find job postings by different companies that Meton invested in. If you're interested in taking a look, this is the QR code. And yeah, we're going to post the slides online as well. So we would be really happy to talk to you. And then I wanted to mention that we already have the next date too. It's going to be, the next Meton AI Times are going to take place on 23rd July. We're going to meet here again at 4 o'clock in the afternoon. And it's going to be a panel discussion. It's going to be a joint project with Cinkátko one more time. So Misha Gregorová from Meton is going to be moderating the discussion, and it's going to be a couple of CEOs and CTOs talking with young students from ČVUT, from CTO in Prague. And also in this event, we will present the results of the questionnaire that some of you filled out when there was the competition for the Lego that we did and announced, I believe, last time. So yeah, that's going to be the content of the next event. Hopefully, it's going to be light summer topic, and yeah, we will be excited to see you here. And with that, I think we're at the end of today's event. There are refreshments in the back. Feel free to stick around. And again, thank you all for coming. Thank you for joining, and thank you, Petr, for the wonderful presentation.